When it comes to exponents, if you are given, it's all about recognizing the base and exponent. And if you are given a power like the one that is given to you right now, that two, we call it the base, and the three will be called an exponent or index. Some call it power. Now, note that the exponent tells you about how many times a base has been multiplied by itself. Okay. Now, in this example here, you will note that 2 has been multiplied by itself 3 times. The first exponential law says that when multiplying the same bases, you must add their respective exponents. Question is, why is this the case? The underlying reason is the fact that there's a very close relationship between addition and multiplication. I think Zulu and African languages say it better. To multiply in Zulu means ukwandisa. Ukwandisa means you're adding to what you have, which is the same phrase when it comes to Sotho adisa. Now, if you have 2 cubed, to expand that, you will write it as 2 multiplied by 2 multiplied by 2. That is you multiplying the base by itself 3 times, which in this scenario will give you 8. By multiplying the above by another 2, which is 2 cubed, if we were to multiply that by another 2, you will be increasing the number of times you're multiplying 2 by itself. Now you're no longer multiplying 2 by itself twice, but instead 3 times. Therefore, if you multiply by 2 by itself, and that is already multiplied by itself 3 times. If you multiply by another 2, it will give you 2 to the exponent of 4. Okay, now this is what I started with when I started the lesson. Let's try and expand each of the following. How do you write the following in expanded form using what I've just told you now? Give yourself 2 minutes to do this. Now, 2 to the exponent of 4 will be 2 times 2 times 2 times 2. Okay, you multiply 2 by itself 4 times, and 3 to the exponent of 5, you will multiply 3 by itself 5 times. 3 to the exponent of, 5 to the exponent of 3, you'll multiply 5 by itself 3 times. And 2 to the exponent of 3 times 5 to the exponent of 4, you'll multiply 2 by itself 3 times it by 5 multiplied by itself 4 times. X to the exponent of 6, you multiply x by itself 6 times, and x squared times y cubed will multiply x by itself twice and multiply that by y multiplied by itself 3 times. Okay, now let's apply the exponential laws to reduce the following. The first one will be 2 to the exponent of 4. You write it as a single base and you add the exponents. Note that if the exponent of the base is not written, then that base has an exponent of 1. So you will simply write it as a base of 2 and simply add the exponent. The base remains the same. All you do is to add the exponents. I'm emphasizing that because a lot of my kids decided to multiply 2 with 2, and that gave them 4, and they multiplied it with 2, it gave them 8, they multiplied it with 2, it gave them 16, and they wrote it as 16 to the exponent of 4. No, 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 no. You keep the base as it is. All you do is just to add the exponents, okay? Similarly here, we multiplied 3 squared with 3 to the exponent of 1 times 3 to the exponent of 5. When you add the exponents, you'll have 2 plus 1 plus 5, and that will give you 8. So that's why we have 3 to the exponent of 8. Number 3, we'll have 5 cubed times 2 to the exponent of 4. Number 4 will have 2 cubed times 5 to the exponent of 5. And number 5, let me just explain this one because it's very, very interesting. You will write it as a base of x. You add the exponent, so 2 plus 1 is 3. 3 plus 1 will give you 4. 4 minus 1 will give you 3. 3 plus 1 will give you 4. Plus 4 plus 1 will give you 5. That's why we end up with x to the exponent of 5. The next one will have x squared y to the exponent of 0. Please note that when it comes to exponent, any base that has an exponent of 0 will give us 1. Okay. One of my students asked me, what is the principle behind that? And I wouldn't want to explain that right now. I will explain it later on, probably in grade 10, 11, and so on. For now, I just wanted the grade 8s to understand the basics. And once you understood the basics, I will explain as to why we say that any base to the exponent of 0 is equal to 1. Okay, it goes back to the multiplicative inverse. All right. Now, if I have this, obviously I'll end up having x to the exponent of 2 because y to the exponent of 0 is 1, and anything you multiplied by 1 is anything. That's why we have x squared times 1 is x squared. It remains the same. 1 keeps it as it is. We call it the multiplicative identity there. Okay. Now, let's get deep into it. If I have 2 cubed times 2 squared, what is the answer to that? Give yourself 5 or 6 minutes to do this and come back to watch the solutions. What are we going to get for the first one? Let's just see. You will have 2 to the exponent of 5. The second one, you will have 3 to the exponent of 10. Number 3. What are we going to get for number 3? We'll have 5 to the exponent of 1 plus 3 plus 1 plus 7, and 2 to the exponent of 1 minus 2 plus 1. 5 will end up having an exponent of 12. 2 will have an exponent of 0. Your answer will be 5 to the exponent of 12. You can put that into your calculator to find out how much that will give you. Okay, what about this one here? And this one. Please try those on your own, and if you would like to send me answers, just do so. I've got my email under comments. Just check my email there and send them to me. Okay. For now, I will move into what we've been doing thus far, which is applying the multiplicative law. So as I have proved in all the examples I've done so far, multiplication of same bases leads to addition of respective exponents. So if I've got 5 squared times 5 cubed, that will give me 5 to the exponent of 2 plus 3. And 2 plus 3 will give me 5. So I end up having 5 to the exponent of 5. If I have a to the exponent of n times a to the exponent of 2n, I will write it as a single base, which is a, and just add the exponent. 1n plus 2n will give you 3n. okay? But what if I have b to the exponent of n times b to the exponent of m? Now I have 1n plus 1m. That will give me 1n plus 1m because you cannot add unlike terms. I will explain unlike terms and like terms when we start with algebraic expressions. All right. Do this one quickly. What is the answer to these? It's just a continuation of what we did earlier on. Okay. Try them on your own and check out these solutions here. Now, x to the exponent of 3 times x to the exponent of 11, that will give me x to the exponent of 14, okay? For number 2, to multiply, you will start with the coefficients first, okay, with the numbers that is. So you will start by multiplying 3 with 4, and then with 2, that'll give you 24. And when you multiply the y's, because the y's are the same basis, you will just add their respective exponents and write them as one base, which is y, okay? And that's why we'll end up having 24 y to the exponent of 4. What if we have something like this? How do we simplify this? Okay, we've got 1 there, we've got 1 here, we've got 1 there, we've got 1 there, we've got 1 there. We are adding 1 5 times, which is simply 5. So you end up having x to the exponent of 5. What do we get here? I'll tell you the answer. It is 16 to the exponent of 10. You are right. It cannot be 16 to the exponent of 10. Remember what I said. You keep the base. All you do is just to add the exponents. Okay? You'll end up having 2 to the exponent of 10. All right. Here, what do we do? When it's mixed like this, I prefer to group them. Multiply the m's on their own and multiply the n's on their own, which is a bit easier. Now, when it's like this, it's easy for you to determine what you need to do. With the m's, you'll have m to the exponent of 4. With the n's, you'll have n to the exponent of 3. Otherwise, you just go straight to the answer. Okay. What about this one here? It'll be 3 to the exponent of 11. And this one, it will be m to the exponent of 15. Let's move on. Here we'll have x to the exponent of 5 times y to the exponent of 5. Try this one. What are you going to get here? Let's start first by pushing the p's, right? I'll start with this one. It has an exponent of 2, and that p will have an exponent of 6, and this p here will have an exponent of 7. So you will have to add 2 plus 6 plus 7, and that'll give you how much? 15, if I'm not mistaken. Let's push the q's now. To be in tune, you will take this 2, add it with 5. That'll give you q to the exponent of 7. And then you minus the 6. And that'll give you q to the exponent of 1. And normally 1, we do not write it. So we'll just write it as p to the exponent of 15 times q to the exponent of 1, of which we do not write. Okay. If you got that one right, you should be able to do this one. What do we get here? You will get x to the exponent of 4 times y to the exponent of 2. What about this one here? Just because they're x's, yeah, just leave them behind and add or subtract the coefficients, okay? Just like that, you leave the x's behind in the past, okay? You just add the coefficients. So we'll have 1 plus 2 minus 3, it gives you 0, all right? So we'll end up having 3 to the exponent of 0x, and 0x is the